Following up on a great discussion about shark exorcisms, so not sure how we're going to go here, but we'll see how I do. I'm Shelley. Thank you all for the introduction. And today, I'm going to talk a little bit about the process of API modernization. For a little bit of background on me, I work full-time on the Electron open source project on behalf of GitHub, where I've been for about 2.5 years. This work has allowed me to explore and participate in a pretty wide range of open source projects and committees, like Node, Chromium, and TC39. I'm based in San Francisco, although I work with a fully distributed open source team in the kind of asynchronous way well-suited to the open source ecosystem. Modernization means very little out of context, especially in the software world. It's a fun, fancy buzzword, but I can't really give a whole presentation on how you can apply its principles to your own organization without first establishing some shared context for what I mean when I say it. In service of that goal, let's start with the most basic definition. As we see here, modernization is the conversion, rewriting, or porting of a legacy system to a modern language, software library, protocol, or hardware platform. That's an OK start, but it still leaves us with kind of a lot of unanswered questions. What does it mean for something to be modern? There's still a lot of wiggle room in that definition I just gave. And even some of its discrete components might not be understood in the same way. Besides that, can modernization even be universally understood across contexts? The answer to this question, for better or worse, is that it depends. I know that probably isn't the answer a lot of you want to hear. It depends might feel a little bit like running a non-deterministic program. It doesn't really inspire a whole lot of confidence. But I'm not here today to give you 25 minutes worth of maybe. So let's unpack that further. Modernization is something that takes on different meanings according to different contexts. And so for you to understand and gain concrete lessons from its discussion, I'm going to ground it in some practical examples from the project I work on every day, Electron. Modernization, as we'll soon see, can also feel a little bit like this. There's not always an obvious path to take. And whichever one you do take may well lay waste to your best laid plans. You may now be wondering, why is modernization even something we want to do? I haven't exactly opened with the most shiny and positive take on the whole thing. On principle, we modernize in order to retain and extend the value of a legacy investment, which is an investment that continues to provide core services to an organization. Many factors might compel developers to do this, but for better or worse, at a high level, it's something most of us are at some point going to need to do. Some of you may be familiar with Electron, but before we really get into it, let me do a brief overview. Electron is a JavaScript framework for creating desktop applications with web technologies like JavaScript, HTML, and CSS. It can be used on Windows, Mac, and Linux, as well as a variety of other software architectures and platforms, including Windows on ARM and Raspberry Pi. It works by integrating Chromium and Node and adding an extra layer of Objective-C and C++, which enables you to create fully formed GUIs, as well as take advantage of file system and networking capabilities with Node. Typically, desktop applications are written in the native language for that operating system. If we take Windows, Mac, and Linux, we now have 3 teams writing 3 different apps, which can be costly in terms of monetary resources, feature velocity, and developer hours. Electron enables you to write your app once and have it run on all applicable platforms. We also can't understand how modernization affects users without first having a brief chat about API versioning. An API is, fundamentally, a contract that you, as a maintainer, establish with the people consuming your API about how it's going to behave. When a developer commits to using a library or framework, they're signing their end of this contract, and you, implicitly, are signing yours. You can think of an API a little bit like buying a new car. When you buy that car, you've probably got a pre-existing set of expectations about how it's going to behave. Now imagine you get out on the highway and you're going 80, and then suddenly you realize that the gas pedal and the brake have switched. You know, I don't know about you, like I love a good adventure, but I really like knowing how my gas pedal is going to behave 100% of the time. Your users are the same. They don't want to commit to using something they don't feel like they can trust. One of the more common ways to set expectations for an API contract is known as semantic versioning. In this approach to versioning, a version is specified with 3 numeric components: major, minor, and patch. As the name suggests, each of these components confers meaning. And so it allows the consumer to quickly understand how updating to any given version will inform the behavior of their app. Major version bumps indicate breaking, backwards incompatible changes. Minor bumps indicate new, but backwards compatible functionality. And then finally, patch bumps indicate fixes to existing functionality and nothing new. For our purposes today, I'll be focusing on 3 buckets: modernization spurred by updates to platform, modernization related to dependencies, and modernization related to programming language specification. Operating systems maintain their own unique API surfaces, which don't always conform to the kind of API contract you might want or expect of them. They can't really adhere to something like Semver, and so oftentimes they choose to make changes to their API in lockstep with new operating system versions. As you might imagine, this can create some mismatches with libraries, which often need to work across multiple versions of a single operating system. One example of this is Apple's AppKit framework, which contains all of the objects that a developer needs in order to create applications for Mac, like windows, panels, buttons. You get the idea. As such, frameworks like Electron, which hook into and depend on this framework, need to monitor and adapt for changes as Apple releases new versions of its operating system. The question we then want to ask ourselves is, how do we account for this in an optimal way? Let's look at how Electron handled a recent snafu with just such an issue. If you've used Mac OS, you'll know that there's a tray bar at the top right of the screen. This tray can contain individual elements, which are called NS status items. Electron exposes a module that enables you to create and control individual instances of these elements through what's called the tray module. From the very first release of macOS 10.0 until 10.14 Mojave, developers could use instance properties on these items to customize their appearance and behavior. In macOS 10.10, the button property was added, which allowed you to customize appearance and behavior of these items in a similar way. And at the same time, the pre-existing instance properties were deprecated. Finally, in macOS 10.15 Catalina, the previous instance properties ceased to work. This actually caused some pretty unfortunate consequences in Electron, because we'd been relying on those instance properties in our tray functionality and not the newer button approach. As a result, some of the tray appearances just actually stopped showing up on earlier versions of Catalina, which, as you can imagine, was not super awesome for us. As a result, we had to quickly and efficiently modernize our code for these new constraints. But there was one catch. The button property no longer allowed developers to manually manage highlighting of NS status items. Since we exposed a method to allow developers to do so, this was by definition a breaking change. We ended up, as a result, removing this method from the tray module in Electron version 7 since at the time, it was in the early stages of beta, which meant that we didn't feel we'd be breaking our API contract by doing so. As you consider your own app's platform modernization strategies, there's some clear things I think that Electron's experiences demonstrate here. We don't always make the right choices, and so we want to share both our successes and the things we feel like we could do better. We determined this breaking change in practice because one of our core team members was testing on Catalina. But this was a lot more reactionary than I think we would have liked. It's important to strategize research around upcoming platform changes so that you don't end up scrambling to minimize breaking changes like we did. We also could have taken the opportunity to refactor the tray module in advance for these platform changes, so that we could have avoided users experiencing any breakage on any supported versions. Next up is language modernization. Language modernization is modernization relating to the programming language in which a library or framework is consumed. This is an important distinction because Electron's underlying architecture is actually written mostly in Objective-C and C++. But modernization in this context for Electron would be that relating to updates to the ECMAScript specification for JavaScript, since it's a JavaScript framework. A variety of these are outlined here, and they include things like promises, async await, optional chaining, or nullish coalescing. We get some of these updates for free in Electron when we update our dependencies. But we'll save that for a little bit later and focus on the more costly updates right now. A notable effort in the Electron codebase this past spring was the Promisification initiative, which has taken most of our asynchronous APIs and converted their usage from callback to promise-based. This happened for a variety of reasons. Callbacks have their place, but programmers can write arguably more elegant code and unlock the doors to even more modern functionality like async and await when they can use promises. So how do we do this? And how do we communicate that to our users? We actually chose to do it natively. And I see some of you already look a little bit sketched out. Aren't promises a JavaScript thing? So yes, but also kind of no. To do this, we used an engine called V8, which Google wrote for Google Chrome. It implements the same specification as JavaScript, but in C++. By creating a wrapper class over its promise functionality, we could enable our APIs to cleanly return promises at the native level, so that we didn't need to paper over them at the JavaScript level with something like util.promisify. So basically, promises, but with surprise multi-threading. This looks a little horrifying, I recognize, but actually it ended up being pretty fun. As we undertook this initiative, we also created a document to track the progress of this migration and designed our changes to make sure that they were backwards compatible where possible. By supporting both callbacks and promises for an entire major version, we made it such that users could be confronted with these changes at development time and have enough lead time to make changes that didn't end up affecting their end users in negative ways. Was this a totally smooth process? Also, no. At a high level, we accomplished our goal with relatively few hiccups. But that's not to say we didn't hit any snags. In one of our more fun bugs, we actually found out that if you called an API in just the correct way, you actually ended up triggering an uncatchable native promise rejection, which happened because we tried to convert types in C++ from one to the other in a non-safe manner. We actually consider that almost like a terrifying accomplishment. So what did we learn from that adventure? And what can you take away from that? For starters, deprecating methods well is a non-trivial task that shouldn't be done haphazardly. We should have been more clear up front that these changes wouldn't all take place in a single major version, since we occasionally still get issues saying that promise-based functionality isn't working for a version in which it did not yet exist. We're looking towards our docs to help us fill that gap. We do want to continue with our transition path pattern, however, because we did get good, clear feedback from our users that it enabled them to update in a smooth and bug-free way. Finally, we move to dependency modernization, which is modernization that enables more access to more modern capabilities through dependencies, and not through code we've written ourselves. For Electron, 3 key dependencies of this nature are Electron, or Node, V8, and Chromium. Updating each of these gives users access to more modern features, but also brings with them potentially breaking changes. And so we need to be mindful about how we coordinate these upgrades. Upgrading Node, for example, gives us access to new file system and networking capabilities, like, for example, recursive RMDir. Since Node also adheres to Semver, minor bumps therefore necessitate minor bumps in Electron. By upgrading Node, we also ensure that we stay on top of security updates and see performance improvements. Chromium is a bit of a different story, in that they don't really adhere to Semver and stay evergreen. Security and performance are our primary forcing functions here, as the most secure Chromium is always the most recent. And performance of Chromium, and therefore Electron, is always going to be better the more recent a version that we're bundling. Finally, V8. I mentioned V8 a bit earlier on, as Google's JavaScript engine that implements the ECMAScript specification in C++. For Electron's purposes, it's also important that we try to use the latest compatible version. This enables us to access the latest features of the JavaScript spec, including some you can see in the tweet on the left-hand portion of the slide there. V8 also works extremely hard to be performant. And so as we look to make Electron faster and less costly, it's in our best interest to keep as close as we can. And now to the lessons. We've managed to be constantly updating against Chromium's tip of tree, or most recent commits. But our newly short feedback loop has not been without a few difficult lessons. Sometimes, your dependencies won't all play nicely together. And as such, it's important to make your version bundling decisions as far in advance as possible. We didn't do that very well for Electron version 6. And so the version that shipped with fairly early betas was actually a version of Node that was slightly more recent than stable, because it was a few weeks earlier than Node version 12 was scheduled to go stable. This slightly hurt our ability to communicate with our users, because it disrupted, even though it's in a small way, our ability to set proper expectations for the stability of the versions that they could expect. You, as a developer, probably want to give your users the access to whatever you've defined as the latest and the greatest. And your users also want to access these latest and greatest. Without communication, however, these two converging desires are like a chemical reaction that, given just the wrong measurement of a single ingredient, can explode the whole lab. What if your users have different understandings of latest and greatest than you do? That's a non-trivial possibility, because you have different constraints, opinions, platforms, and considerations than they probably will. The only way to set expectations and make sure your users are aligned with your efforts is to ensure that you've communicated with them as far in advance and with as high a degree of detail as possible. To that end, optimal communication can be understood to fall into 3 big buckets: ensuring redundancy, communicating early, and providing context. Your users aren't and shouldn't be responsible for digging into the deep, dark depths of your documentation to figure out what's coming down the pike. That burden is on you, the maintainer. Upcoming changes, especially those that break or alter existing functionality, should be as discoverable and as context-rich as you can make them. If there's only a single place that your users can go to gain context on upcoming changes, that's what's known as a single point of failure. The opposite of that, in my opinion, is not no points of failure. It's many discrete points of failure, so that your users can miss 1 or 2 different notices and still gain a concrete example of upcoming changes and how they may affect them. Communication is always great, on principle. But not all communication benefits your consumers equally. Telling your consumers about a change, right as it's set to take effect, is unfortunately indistinguishable from not telling them at all. You should look towards informing your users of upcoming changes as soon as you feel that there's no risk you'll need to recant what you've told them. Your users should be made aware of when a change is scheduled to take effect, on what versions that change is scheduled to take effect, and how much work those changes will need to be accounted for by your consumers. When you make changes to your API surface, there's going to be a reason that you're doing that. Unless there's a security-related or other confidential concern, why not share that context with your users? It'll help them understand your processes and likely better foster community relations. When providing that context, there are 4 main questions you'll want to take into consideration. Why are you making those changes? How does this benefit your users? How might this hurt your users? And what do they need to do to prepare for those changes? Answering these questions to yourselves, both before and during the development process, will provide a strong contextual base for smoother updates as your project chugs along. Unfortunately, even communication can hit up against its limits. You can communicate your list of upcoming changes as far in advance as you'd like. But if you've got 100 changes in every major version, the cost of updating your library might become too high for some of your users. To that end, it's important to be intentional about minimizing churn. You don't want to throw your users into an endless hamster wheel of terror, because as you can see here, when you do that, everyone gets swept into the maelstrom, and not just your consumers. As vital as modernization can be, the best choice sometimes can be to defer or not to modernize at all. In considering whether or not this is the best decision for you and your team to make, there are several things you'll need to take into account. Chiefly, as I've said repeatedly throughout this presentation, context is key. The information you have today might guide you towards a different conclusion than the information you have 6 months from now. Codebases live and breathe, and that decision doesn't prevent you from making different decisions down the line. You want to ensure that any changes you make will have veritable positive impact on your project. Perhaps end users won't see a change, but your team will decrease its maintenance burden. The only real danger lies in modernization for its own sake. If you can't prove impact to your project, you should ask yourself if these developer hours are really worth it. If a decision to modernize will cost your team productivity on something more pressing, increase maintenance cost, or increase technical debt, you should likely wait. These examples I've provided will hopefully help you shed light on how to make better choices within your own code bases. But our constraints and considerations are different than yours. And so as a result, our decisions may also be. When you return to your code bases on Monday, I encourage you to view these examples as heuristics rather than rules. Rules hold fast, while heuristical lessons like these require context-specific interpretation. You have primary responsibility for the success of your users. And so you want the barrier to their success in using your library or platform to be as low as possible. All modernization requires non-trivial work. And if it's something that matters to you, it should never be planned as an afterthought. Finally, come talk to me after this. I want to hear from you. If you want to talk about the future of Electron, the divide between the web and desktop, what it's like to work full-time on open source, I'll be around. Thank you so much.